Hello, ladies and gentlemen, and welcome back. We're on our very second last question, question number 24, on the 2017 Pascal contest. A town has 2,017 houses. Of these 2,017 houses, 1,820 have a dog, 1,651 have a cat, and 1,182 have a turtle. I don't know why we'd have a turtle and not a mouse, but okay. If X is the largest possible number of houses that have a dog, a cat, and a turtle, and Y is the smallest possible number of houses that have a dog, a cat, and a turtle, then X minus Y is... Okay. So we want the difference of the largest and possible values of sort of the overlap of a Venn diagram. So we can think about total, the universe is this rectangle here, and then we've got the dog ones, cat ones, and the other one was turtles. So we can represent a Venn diagram. The total of all the numbers that we could put in this Venn diagram should be 2017. The total of all the numbers in the T circle is going to be 1,182. The dog one was 1820, and I think the cat one was 1651. Yeah, 1651. So the question is, how can we fill in these houses? Here's 100 houses that just have a dog. Here's 50 houses that have no pet. Here's 900 houses that just have a turtle. Here's 10 houses that have a turtle and a cat. So we have to sort of understand how to read a Venn diagram to make sense of the pictures I'm going to draw. Okay, so we need X, the largest possible overlap, and Y, the smallest possible overlap, which I would have thought would be 0, but the numbers are so high, maybe there's not a way to disperse everything and not have an overlap. Now, in terms of X, there are only 1,182 turtles, so at most, X is 1,182. This doesn't guarantee that X is 1,182, because maybe there's some way to make to not make a Venn diagram that has 1,182 in the middle. Actually, let's try to do that now. A little bigger, so the numbers are more readable for people on screens that are not quite as good. Okay, so we'll still have dog, cat, turtle. Maybe I'll want to color code this in a little while. But if I put 1,182 here, that's all the turtles. So there are no just cat and turtle houses. This is cat, turtle, no dog. This is turtle, dog, no cat. And this is just turtle. So there's no other... The numbers inside the circle have to add up to 1,182. And now, cats are the next smallest. And remember, I have to have a total of all the numbers be 2017. So cats are 1,651. So how many are left over to have cat houses? So 1,651 minus 1,182 cat houses already accounted for. 469. I'm going to overlap as much as possible. Put them in with the dogs. So now the total number in all the cat circles is the desired 1,651. And so now we've got 1,651 dog houses, because they're both dog and cat, or dog, cat, and turtle. And 1,820 of them minus 1,651. There'll be 169 just dog houses. The total of all the numbers so far is 1,820, so 2017 minus 1,820 is going to be 197 houses with no pets at all, and that would be a Venn diagram with the maximum X being 1,182. Okay, not so bad. It's important, by the way, to verify that a Venn diagram with 1,182 does exist. The reason being, and I think this is going to come up more in the second half when we try and figure out what Y should be, if I just say, the smallest Y can be is 0, no overlap at all, Well, there's a lot of constraints going on here. A certain number of dog houses, cat houses, and turtle houses, and a total number of houses of 2017. If the total number of houses were not restrained, then yeah, you could just say, oh, the middle number can be 0. But we have to actually exhibit and show a Venn diagram so that I know y has to be 200 or whatever like that. Okay? So we'll explore this more as we dive in and try and figure out what y is. Now, y is the smallest number. Okay. Well, I'm going to erase these numbers here. They've already proven their point. And now the challenge with the Venn diagram is there's a lot of numbers here. Just a lot of numbers. Y is going to be our value here, and I'm going to say y must be at least. So eventually I want to get some sort of equation like y less than or equal. I mean, I probably could have started this the same way and then eventually got y must be at most 1182 and things like that, and that would have gotten x, but ultimately we're looking for y has to be greater than or equal to something. And then after we figure that out, we'll let y be the smallest of those values. X minus y will be what we're looking for here. Okay. So the problem with Venn diagrams is there's so many other numbers. G is the number of houses that just have a turtle. Can we figure out G? Can we get constraints on G? How about B and E? Maybe we can only talk about D and F together and never talk about them separately. This can be very hard if we view the problem this way, because then that's, 7 unknowns? In addition to our y value here. So rather than try and say, okay, we're going to get that smallest overlap, let's talk specifically about the possibilities for the number of cat and turtle houses. Let's just go animal by animal. I think that might be the best way to do it. The turtles were what limited us for x, so I'm going to start with turtles again now. So whatever y is, actually, maybe I shouldn't say y is this one. Maybe I should call it z. So z is greater than or equal to y. But it's still a number of turtles. So the number of things and this is where I should really use color. I've got colored pens for a reason, why not use them? So everything out here is 1182 minus z. So this is the number of turtle houses that have a dog, a cat, or neither, but not both. Okay? So this number itself is restrained. So this must be less than or equal to 1182 minus y. So that's the purple value. Okay, where to go from there? So we sort of talked about turtles, and if you wanted to, you could give these things names like A, B, and C, and what I'm really saying is A plus B plus C is less than or equal to 1182 minus y. Okay. So now I want to talk about cat houses, I think, in some way. And I can't forget that we have an overall constraint of 2017. So the turtles all have to add up to 1182. That's the number of houses we have to have represented here. So what's left over to work with is all this blue stuff, which is 2017 minus the turtles. And that doesn't really give me any inequality stuff. So, maybe we include my little Z here. So that would be 2,000. So the blue stuff is going to be at least, because every time we do a subtraction, the sign's going to flip. Here we did 1182 minus the Z, the sign flipped to a less than or equal sign. So that's got to be the blue stuff, and that includes our good friend Z. So 1182, so 2017 minus 1182 is 835 plus Z. Okay. So really the blue stuff is exactly 835. I feel like I've gone around in a circle. So maybe approaching this starting from Z isn't the way to go. Maybe we go outside in. So I'm going to get a new page, and instead of starting from the inside and then going turtles, cats, dogs, maybe we start with the number of dogs. Or maybe we start with the number of turtles but go outside in. There's so many circles here, and I feel like there's so many possibilities. So cats, turtles, dogs. So what do we know? Well, we know that there are 182 dog houses. And that tells me 2017, we already made this calculation, 197 non-dog houses. Problem is, I don't know where that is that 197, is it all out here? Is it all in the cats? Is it specifically in this overlap over here? Okay, I know for a fact 197 non-dog houses, but where can that be? Okay, I feel like now if I said something like the number of non-turtle houses is therefore at most 197, actually that does make sense. And then that sort of gets me closer to the Y here. And that's actually putting a constraint here. So, question is, do I want to go with the turtles? Because cats is the next most. So, the number of cats and the number of turtle houses, so this overlap here, cat and turtle and not dog, is at most 197. That's true. And I like the positioning of this as opposite to the whole dog circle. So 1820 in here, and at most 197 here. I mean, that's true. There's also at most 197 here. I don't know where I want my 197. I'm going to try and avoid... So the thing I'm thinking about is this. We are constrained with the number of houses, 2017 at the most. Now, 1820, 1182, and 1651, these are big numbers, and if I give all the dogs their own home, all the cats their own home, all the turtles their own home, I'm going to get over 2017. So what I want to try and do is overlap as much as possible. That's why I've chosen to talk about cats and turtles and not dogs, rather than saying while the greatest number of only cat houses you can have is also 197. True, I don't think I want to focus on that. Okay, I want as much overlap as I can possibly get. And so now the question is, do I work this from here, or do I now say, okay, well, the cats are 100 or 1651. What's the most we can have in the dog, turtle, and non-cat houses, and try and get sort of this pinwheel filled up? And that might not be a bad strategy either. But I now have a less than or equal sign, so this might be useful. Okay, so we want to talk about the number of cat and turtle and dog houses. We want that to be at a minimum. We want the minimum of that. So ultimately we want to say number of cat and turtle and dog. Okay. So these two values added up are exactly, so is at least y. So these two values added up give me the whole of cat and turtle intersection. Okay, so problem is one of them is a greater, less than or equal. One of them is a greater than or equal. So, is there a way I can talk about max number of cat and turtle houses? Period. Well, let's see. Okay, so we talked about the dogs, and now the ball's in the cat's court. So there's 1651 cat houses. At most 197 have a turtle and no dog. And actually, we could broaden that to just at most have no dog. Alright, we didn't have to go with cat and turtle and not D here. We didn't have to be talking about that blue overlap. We could have talked about the whole thing. So, at least 100, or I don't know why I keep saying 100, 1,651 minus 170 have cat and dog. Yeah, I'm going to ignore this. I'm going to say, so the number of cat and no dog is at most 197. So now I'm talking about this whole overlap is at most 197. Okay, so that means that I now have an upper bound or a lower bound on this purple section. And that's 1651 minus 195 or 97. So the total in there is at most 1454. All right. So now, so that's the total in there. So I could say something like there are at most 1454 minus 1182 that have cat and no, this would be at least as well, wouldn't it? So, let's go back to it. I know we have. So I know there are 1182 turtle houses. Okay, now the turtles overlap here. So there could be some gap here. So the total in here is 1454. Now at most the complete overlap is 1182. We've talked about that, but we want to talk about at least this y. So at least this y, and then we have this total here. So could be 1454. And then this number, well, how can we talk about the turtles? So the turtles, I think, are part of everything that is outside the purple. This question seems to be taking a lot for 24 on Pascal, but maybe I'm just not viewing it the right way. Anyway, so we have 1182 turtle houses here. So we have 2017 minus 1182, which is 835. So these are 835 non-turtle houses. Therefore, at most 835 cat and dog and not turtle houses. And so what does that leave me? 1454. So this guy here, this little extra gap, is at most 835. There might be other numbers other places, but that's at most 835. And so number of cat, dog, and turtle is at least 1454 minus 835. And that would be 619. And so I'm saying there has to be at most 619 there. Okay? And let's see, does this reasoning follow through? So it has to be all the dogs there. At most, all the non-dog houses are also cat houses. So that'd be at most 197 there. So if there's at most 197 there, the other part of the cat circle is at least 1454. So an at least minus an at most gives us an at least as well. And at most, all the non-turtle houses are stuffed in this purple-white overlap. So that'd be 835. Yeah, it makes sense. Let's see if I can just finish this off and turn it into a Venn diagram. Because that's sort of the ultimate test of, did I mess up an algebra? So I think this should be y. And so 619 there. I'll put all the 835s there. That means we have to have the total number of 197 be in these two overlap bits here. I don't know if it especially matters where they are. Does it matter where they are? 835 plus 619. Should I put all of them here? And then what would I need over here? 619 and 1182. So we'd have 563 here. 563 plus 835 plus 619. Not quite, because that's going to give me 2017 in here, so that was too much of a number. So maybe I can't put all 197 of them there. What if I put 197 of them here? So now in the turtle section we have 619 plus 197 turtle houses already accounted for. That leaves 366 here for this overlap. And if these don't add up, then we've done something wrong. But nope, we've got 1820 overall. And so this would be an example where we get 619. And I know I can't do better because all of my at least at most reasoning. So x is 1182, y is 619. This question was annoying because I was not seeing the Venn diagrams properly, but that happens to everyone at times. So a difference of 563, and this should be one of the answers, unless I've done something terribly wrong. No, there it is. It's C. And really, the only thing that we could have done better would be E. So I'm even more confident, because with a question like this, I would not make the smallest available answer the smallest available answer, nor would I make the largest available answer the proper answer. So I'm bolstered by that fact, but I'm also confident in my logic of my, at this many dog houses, so we have to have at least this kind of overlap and there. But I'll be honest, Venn diagram questions can be quite tricky. I teach a finite math course, and Venn diagrams, we do those at the start, and people have a lot of trouble tracing things around there. And, I guess it was even hard on this Pascal paper here. But that was question 24. I'm looking forward to question 25. We'll see if it's even harder. And give it a shot before you watch the next video. And have yourselves a wonderful day in the meantime. So long.